Hi and welcome to this On Maths GCSE prediction for the AQA Higher Paper 2. This is filmed after Paper 1. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction. So this is the Paper 2 prediction for the higher grade 1 to 9 paper for the AQA GCSE. So we've had Paper 1 and I've had a rummage through Paper 1 and have taken out all the topics that have already come up that I don't think will come up again and generated a Paper 2 prediction. This should be a lot more accurate than Paper 1 because now we have a past paper and we kind of see how AQA are setting things out. Now, something I've not done on the past on the predicted paper, which obviously the AQA are opting for, is the multiple choice style questions. The reason being is it's only with AQA really that they pick that style, and the questions I do should answer those questions anyway. If you want to practice the multiple choice style questions, if you go onto Minute Marks on onmaths.com, then that has loads and loads of multiple choice questions that will help you get used to the style of the AQA exam. So the way this works, if you're new to this, is I'll go through all the questions, but there are only one question. There's only one question on YouTube because they can't have multiple different numbers and each time, etc. If you want to have a fresh go at the paper, then go to onmaths.com for free and you can try out the paper with different numbers each time so you're remembering methods and not just answers. And that's really important that you practice actually trying to figure out yourself rather than just, oh, hang on, this one was 20 or this one was 25. So if you go onto onmaths.com, it's completely free. It will grade your exam at the end, or it will grade your paper at the end, and it'll give you the amount of marks. If you sign up for free, then it can save your marks as well, so you can see if you've improved. You can go off and revise and try it again and see whether it's gone up. The video I'm doing now will just go through all the methods to help you out. So if you're stuck on a question, you can go back to this video and see how it's done with different numbers, and hopefully you can apply that to the question that it generates for you. The website has loads of other stuff. It has topic busters, which are all the GCSE topics. So if you feel that there's a topic that's not on this paper that you want to practice, go onto the site. Everything we provide is completely for free, so use it as much as you want. And that's it. I think I've run out of things to say, so without further ado, let's get started. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures. So just put them all in. Now, if your calculator is set to a mode which is going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in your answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. 2 minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. The important thing to remember with an estimate question is that you don't get any marks for getting the exact answer. So even if this does come up on a calculator paper, then you won't get any marks for getting the right answer. It wants you to estimate. Normally, that means to round everything to one significant figure. Now there are some exceptions to that. Square roots are an obvious one. If you've got root 82, you won't make that, I should put squiggle lines, you won't make that root 80, you'd make that root 81, because then you'd be able to say, well, that's roughly 9. Anyway, there are some small other exceptions. So let's go through this and let's convert these all to one significant figure. And if I draw some lines in, then that might help me. The line for the first one will be between the 7 and the 3, so that will just be 7. For the next one, the line will be after the 1, so that would be 200. Ooh, switch that back. Get all in the same colour, so that would be 200. Now this is where some people make mistakes. They think that that will round to 0, but significant figures ignore any zeros. It's the first non-zero digit you start counting. So the line will go after the 4. So that will round to 0.5. Okay, now we can times the tops together, or times the two numbers at the top together. So 7 times 2 is 14, with 2 zeros, over a half. And all we can do here is just times the top and bottom by 2. So I can times 14 by 2 to get 28. So 1400 times 2 is 2800. And the bottom times 2, well, that's just 1. So the answer is just going to be 2800 or 2800. Now the point of estimation is you should be able to do it in your head. You have to write down the working out still, but the point of estimation in real life is when you don't have a calculator. So if you're finding something that you've got to do a little grid or something, or work it out a long way, then chances are you haven't estimated enough. So we're given quite a basic diagram. We're given a pair of parallel lines and we're given 2 angles from them. And angles on the parallel lines, there are 4 things you should be thinking about. So the first one is corresponding, those are F angles. The next one is alternate, which are Z angles. The next one has loads of names. It's co-interior, interior, allied, whichever your teacher says. And the last one is vertically opposite. Now vertically opposite occur in other places as well, not just parallel lines, but that's normally the one that you will be using. So let's have a look. Well, what letter does that make? So if I draw out from the parallel lines, I always say it's the armpits of the letter. So if it's a Z, it's the armpits of the Z. And if it's an F, it's the armpits of the F. Well, this is like an upside down backwards F. So we know that upside down backwards F, any F angles are going to be the same. So I know that's 62 degrees. Now we've got to give a reason. So the reason is corresponding. Now I always got corresponding and alternate mixed up. So I don't know whether this will help you, but I always think cor F ponding and alternate. Please don't spell it that way, but I just literally bung the letter into the word and I've never got them muddled up since. So that might help you. The other one, the C angle, are not equal. So these ones here are not equal. They add up to 180 degrees. So just be careful with that. The rule of thumb is if you're guessing and they look the same, even if it says it's not drawn to scale, if they look the same, then if you have no other memory of what they're likely to be, if you forget about angles on parallel lines, just write down the same angle. If the one's acute and one's obtuse, just take it away from 180 degrees and maybe you'll get some marks. But hopefully you'll remember the corresponding alternate, co-interior or interior or allied, and vertically opposite. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. So this question looks quite complicated at first, but actually there are 2 very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but you know, if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the 2 plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here, because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now, with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now, the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's two decimal places, so line goes down here, and we've got 168.28. Now just be careful that you add on the extra bit. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is we want to do, I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, and the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7,359, times it by 100. And that gives me 66.7617 blah blah blah. So that's to the nearest percent, so that's going to be 67%. So the first thing we're going to do is fill out the table. And so when it's x cubed plus 10, I'm just going to cube the x and then add 10. So 0 cubed plus 10 is just 10. And I always start off with 0 because it's normally the easiest. Then I go for the positive numbers. So 1 cubed is 1, plus 10 is 11. 2 cubed, so 2 times 2 times 2 is 8, plus 10 is 18. And 3 cubed, 3 times 3 is 9, times 3 is 27, so that's going to be 37. Now minus 1 cubed, now some people think that minus 1 cubed will be a positive number, but it's minus 1 times minus 1, which is 1, times minus 1, which actually is going to be minus 1. So it's minus 1 plus 10, which is going to be 9. And then minus 2 cubed is going to be minus 8 plus 10, which is going to be 2. So when we plot this on the graph, minus 2 is going to be at 2, minus 1 is at 9, 0, 10, 1 is 11, 2 is 18, and 3 is 37. Okay, and you want to try and join these up with a curve. It looks like an S, the cubic, like that. Sometimes you get a dip like that. On this one you don't. So let's try and join these up with one straight line. I've already broken that rule. Oh, it's not very easy on this. And I would say that that's good enough. There's a little bit of wiggle there, but I think I can get away with that. The important thing is it goes through all the points and it's just one straight line. You don't do any feathering, and feathering is where you go like this. You know, I've exaggerated it slightly, but you just want to draw one line. Okay, so it says use the graph to find out the value of x when y is 15. So what I'm going to do is I'm going to draw a line across where y is 15. So y is 15 here. And the solution is going to be where the two lines hit. Now I think that's 1.7, so I'm going to go for 1.7 because it asks for one decimal place. Now normally with drawing questions, because people draw slightly different, normally there's a little bit of leeway in it, as long as you've used your graph and you've shown the examiner that you've used that line there. So there are two things going on here. Varies and inversely are two things you need to look out for. Varies could be is proportional to, or whatever. It could say it that way, or it could just say varies. Now the first thing to write down when it says y varies, or y is proportional to, is do this little fish sign, alpha sign, and that means it's proportional to. Now when it says inversely, it means that it's going to be proportional to 1 over x. The next thing to do is get rid of that fish sign and replace it with an equals, and the way of doing that is just times the right hand side by k, which is a constant. So it's k over x. Now it says when y is 15, x is 14, so we can put those values in to find out what k is. So 15 equals k over 14, and we times both sides by 14 to get k equals, and so we've got 15 times 14, which is 210, equals k. So the formula will be, we sort of go back to this one, the formula will be y equals 210, which is the value of k, over x. The next question says find the value of y when x is 10. So y is going to be 210 over 10. That's nice and easy. That's going to be 21. And then it says find the value of x when y is 6. So we're going to have the equation we've written earlier. So it's going to be 6 equals 210 over x. And what you can do here is you can times both sides by x and then divide both sides by 6. And whenever you've got a one number on this side and a bottom of a fraction, you can actually just switch them over by doing that. So it's x equals 210 over 6. So 210 divided by 6 is going to be 35. What's interesting in this question is there's no amount. So what we can do it in two ways really. You could put an amount in, and it doesn't matter which amount you put in. So normally students go for £100 and then see how long it takes to get to £200, and that's absolutely fine. But you don't need to put amounts in, you can just work with the percentage that you've got. So how are you going to do that? Well, first of all, you've got to convert this percentage into a multiplier. We're going to start off with 100%. Compound interest is money you get, so it's going to increase by 5.8%. So that means that we're going to end up with 105.8%. To make that a multiplier, just divide it by 100, so it's 1.058. So that is our multiplier. So year 1, our multiplier is going to be 1.058. So 1.058. So we've increased it by 5.8%. To get year 2's, all you need to do is 1.058, which was year 1's multiplier, so after a year, and just times it by 1.058 again. And so I get 1.119364. Well, if you have a look at this bit here, it means it's increased by 11.9%. Well, we're looking to double the money, so we need it to be a 2 point something. So we keep going, and something you can do is you can type in, you can press on the calculator, answer times 1.058. And if you press equals, it will give you year 3, which is 1.184, blah blah blah. But all you need to do on the calculator is press equals again, and it will just do the times 1.058 to the previous number. So 1.252, so year 5, 1.325, blah blah blah. So it's going to take a while. 1.40. Let's scroll down a bit. So number 7, 1.48, 8 years, 1.56, 9 years, 1.66, 10 years, 1.75, 11 years, 1.85, 12 years, 1.967, blah blah blah. So we're getting close. And 13 years we get 2.081, blah blah blah. So 13 years is going to be our answer. Now there's a few things just to note here. The first thing is that students tend to try and divide. They try and see how many 5.8s there are in 100 or whatever. Don't do that, because compound interest grows each time. So in the 5.8%, if you look at the numbers here, these numbers are increasing and increasing each time, and that's the beauty of compound interest. That's why people say save early. Start saving as soon as you're born. The second thing to note is you might be looking at it thinking, really, do mathematicians do that? Do they just have to sit and write them out? Well, no, actually there are other ways of doing it, but at this level, at GCSE, this is the method to do it. The easiest way I've found to work with bounds is just draw a number line, put the number that you've got, so we're looking at x, put the number you've got in the middle. Try and figure out what the next number down would be. So the next number down would be 1.1 if then rounded to the nearest 1 decimal place. What's the next number up? Well, it would be 1.3. So the next thing to ask yourself is, where's the cutoff point? What stopped it from being 1.1? Why did it round to 1.2? So the lowest it could be is halfway between those two numbers, which is 1.15. So that is our lowest bound, lower bound. The upper bound, the higher bound, would be here, which would be 1.25, but we're not asked for that. So 1.15 is the cutoff point. Now this is a slightly harder question in B because we're given this formula here. Now we've got to be careful when we're using formulas. We're looking for the upper bound of t, so we're looking for t to be as big as possible. Well, for t to be as big as possible, x needs to be as big as possible because we're adding it and we want a number to be big that we're adding. But the bigger y is, the smaller that fraction becomes. So we want actually y to be as small as possible. If you ever think about it, the fraction a half and the fraction a third, which is bigger? Well, a half is bigger. So the smaller the number at the bottom, the bigger the fraction. Anyway, a little bit of a side note, but that's really important that you remember that if there's a denominator that we want it as big as possible to make as small as possible number, or as small as possible in this situation to make the number as big as possible. So we need to find the upper bound for x and the lower bound for y. So using the diagram I drew earlier, 1.25 is the upper bound. Now you might say to yourself, well hang on, no, technically 1.25 would round to 1.3. Okay, let's delve into that a little bit. The actual answer should be 1.249 recurring, but there's two reasons I've not written that. The first reason is that it's a pain to work with. Typing that into the calculator would be a pain. The second thing is that actually 1.249 recurring is the same as 1.25. They are exactly the same number. Now if you don't believe me, a little bit of a side note, a third is 0.3 recurring, 2/3 is 0.6 recurring. Following the same pattern, 3/3 would be 0.9 recurring. But we know 3/3 is the same as 1. So 0.9 recurring is the same as 1. There is no difference, and that's very difficult to get your head around. Anyway, side note over. So the upper bound of x is 1.25. So we need to do a little number line to get the lower bound of y. So it's 4.6. So the next one down would be 4.5. So the cutoff point is going to be halfway, which is going to be 4.55. So that's going to be our lower bound, 4.55. So to find the upper bound of t, we need to do 1.25 plus 1 over 4.55. So let's just do that on the calculator. 1.25 plus fraction button 1 over 4.55. And I get the answer 1.46978 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1.47 because that 9 would round that 6 up. Now there are a couple of different methods for working this question out. What you could do is just draw a line down the middle and split it up into two right angled triangles, and then use trigonometry to find half of BC and then double it, and that's absolutely fine. I don't ever hesitate when there's a cosine rule to be used, so I'm going to do the cosine rule method, but either one will give you the right answer. So it's an isosceles triangle, so it's 6 centimeters on this side, so we know it's going to be 6 centimeters on this side, and we're given A. Well, that's a bit of a hint that it wants you to use cosine rule, and so I'm going to call this one little a, this one little b, and this one little c. So the cosine rule says that it's a squared equals b squared plus c squared minus 2bc cos a. And any capital letters are angles, and any lowercase are always lengths. So a squared is going to be 6 squared plus 6 squared minus 2 times 6 times 6 times cos 100. Okay, and I can just type that into my calculator. So 6 squared plus 6 squared minus 2 times 6 times 6 times cos 100 equals, and so a squared equals 84.502 blah blah blah, and I'm doing the little dashes after the number to show the examiner that I'm keeping it into my calculator. I'm not going to round it. So a is the square root of that, so I might as well just show the examiner that I'm doing that. So I'm square rooting it. So what I'm going to do is just press the square root button on the calculator and then press answer equals, so a equals 9.192 blah blah blah. So to 2 decimal places it's 9.19. Now this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population, and then you capture a few more again, and then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. N, which is the population size, that's what we're trying to find out, is this, it equals M. Now, M is the amount of things that you marked and then released. So on our example here, we marked 4. Times N. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here, it's 2. So let's apply this to the question. Let's try and work out what m is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, or you often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2, and we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. There are a few different ways of answering this question. The easiest way, especially for the way this question's set out, is to count the squares. So first of all, let's have a look and see what range we're doing. We're doing from 10, so from 10 to 40. So we need two things. We need to know, first of all, how many big squares, and we might as well count big squares there are between those two, 10 and 40. And we need to know how many there are in total. So let's just have a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 tools. So that's going to be 22 in that rectangle. That's going to be 10 high. So that's going to be 10 big squares. 1, 2, 3, 4, 5, 6, 7. So that's going to be 14 big squares. And this little section here is 1, 2, 3, 4, 5, 6. So I can use a calculator if it's on the calculator paper. So let's add those together, and that's going to be 52. So there's 52 in total in that middle region. But we need to know how many big squares there are in total. So we go count the other ones. So 1, 2, so that's going to be 6, so that's going to be 12. And that's the same height, so that's also going to be 12 because it's 6 and 6. So we're going to add the two 12s on. So there's 76 altogether. So total is 76. So it says it wants it to 2 decimal places. So it doesn't want it as a fraction, because as a fraction it's 52 over 76. So 52 divided by 76 is going to be 0.6842 blah blah blah. So that's going to be 0.68 8 to 2 decimal places. Now what you could have done is worked out the areas of each of the bars to get something that's maybe proportional to the frequency and then done it that way. But if you can count the squares, it's just much easier and quicker. And sometimes you've got to sort of count half squares or little squares and find a way of doing that. But that's absolutely fine. When you're working with proportions, the actual amounts don't matter.
First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator you can just do 25 take away 13. If it's on an uncalculated paper then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it. And you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, I'll write 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it, so to do that we find the 0th term. So we go back 1, we subtract 3, and that tells me, so I'll say linear. So that's going to be a 7, so we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we've got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together.
Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC, and you can write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51, and the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees, and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away what is it? 180 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150, is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees. And again, it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorise the top and bottom, so put them into brackets, and then something will turn up. So let's factorise the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorise the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, oh, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, oh, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5, and that gets me 1.81712 blah blah blah. Okay, now I need to keep that answer, so what I'm going to do is I'm going to press the cube root button, then I'm going to click inside the root, I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5, and we've got 1.9034 blah blah blah, cube root button, answer plus 5, and we've got 1.9040 blah blah blah. Now we're looking for 3 decimal places, so the numbers we're looking for being the same are these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041 blah blah blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer.
First thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now, at A-level, there are much easier ways of doing this, but we at GCSE have to do this using the Trapezium Rule. Now, the Trapezium Rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between them. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h actually used in the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because a and b are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area, so this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something, okay? Now, we've got 2x squared, and so minus something x. We've got 2x squared minus 28x, so we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared,
Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square. Okay, so I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102.
Well, I hope you found that paper useful, and if you really liked doing that paper and you want to do more, then check out the onmaths.com website, where you can get all the stuff I said at the start of this video and more. I don't know what the more is, but there's probably more on the site as well. If you like this video though, please click like, and if you really like it and want to see more future videos, then please click subscribe. Thank you very much.